There are four keywords we could use for access restriction. These are called access modifiers, and they are: first, public; second, protected; third is no keyword, which we already have discussed earlier; and private, which we use to employ encapsulation from our previous discussion. Now, a package is simply like a folder where you are going to store Java classes, and this is a grouping of related multiple classes. So just like in your Windows Explorer, you have this one as the root directory, and then we have here folder 1. Under drive C, you have folder 1. And under folder 1, you have subfolder 1, 1, and so on. And then maybe under the root directory, you have folder 2, and so on. So a package is just like a folder or a container where you could store several or multiple related classes. So just like in the Windows Explorer, where instead of having all of your files stored in the root directory, you could create folders where you could store related files. Like for example, if this folder 2 is named movies, then this is the folder where you're going to store all your movie files or your video files. And say this folder 1 here is named as MP3 because you're going to store in this folder all the MP3 or the audio files. So we use a folder to hold or to store related files. Like all of this inside MP3 folder are MP3 or audio files, and all the files inside the folder movies are movie files or video files. And maybe you have another folder which is called documents, because you're going to store in this folder all your Microsoft Word documents files. So in the same way, a package is like a folder that we use to store related multiple classes. These classes are related because they are used to perform related tasks or processes. The access modifier public can be accessed by any class. The visibility of any object or fields, methods, constants, or classes that are declared using the access modifier public is that they are visible inside the package and outside the package in the entire project. The second is protected. Any object that is defined using this access modifier can be accessed within the same package and also by subclasses. Subclasses is a topic in inheritance which we're going to discuss soon. The third is no keyword, which we already discussed in the previous video using the example circle and using circle. And an object defined with no keyword can be accessed within the same package only. And lastly, private is an access modifier which makes an object accessible or visible within the same class only. So outside of the owner class, the object, the field, or the method are not visible. Now, we demonstrate this one already with our previous example, the one that we discussed earlier in the last video, that involves the two Java classes, circle and using circle. The visibility of the four access modifiers indicates restriction level. Among the four, public is the one having the most loose restriction, and private is the one having the most tight restriction. If we're going to rank the four access modifiers in terms of the looseness or the tightness of restriction, going to the left, public is the one having the most loose restriction, and then second, going to the right, having tight restrictions. The third is no keyword, and the one with the most tight restriction is private. Recall that a package is a grouping of several related classes. And using packages, we will be able to, number one, control the access from outside the group or outside the package. Second, we will be able to hide the existence of a certain class within the package only. So for example, if this is package A and this is package B, and package A has this class, number one, and the second class is this, and the third class is this. And package B has also these classes, the first one, second, and third class. Let's say, for example, that this class, the first class, is defined with the access modifier public. And also the methods and the fields in that class are also defined using the public access modifier. So what happens is that this class and its fields and methods are visible outside this package B. Therefore, any of these three classes inside package A is able to access or see this class and all public methods and public fields of this class. Again, all public classes or public methods or fields are visible to other classes outside that package. And so this class in package A can see and can access this public class and this public methods and public fields. But say for example, this third class in here is defined using the no keyword, and say the method and the fields are also defined using the no keyword. Now remember, the no keyword access modifier means that that object, whether it's a class, method, or field, that object is visible only inside the package B, inside its package. So only this class and this class can see and can access this class because it is using the no keyword access modifier, which makes it visible only inside the package B. And so all of these classes from or stored in a different package, this class, and this class, they do not have visibility and they do not have access to this class, which is defined using the access modifier no keyword. So in that way, you are able to hide the existence of this class within its package only. It is not visible to other packages. So by using the public access modifier, when defining a class, you are disclosing the class to objects outside of the package. Like in this example, when we define this Java class capsule and using access modifier public, then we are disclosing or we are making this Java class capsule visible and accessible to other objects outside of the package where this Java class capsule is stored. But if you're going to use the no keyword by omitting the access modifier, okay, in this example, we omit the access modifier. So we simply say class and then the class name capsule. So we are actually using in here the no keyword access modifier. In this case, we are hiding this Java class capsule from objects outside of its package. So this time, capsule is no longer visible and accessible to Java classes outside of the package of capsule. So by omitting the access modifier, you are using the no keyword access modifier, and you're able to hide the existence of the class or any object within the package only. So those objects that could access this Java class would only be those classes within the same package as capsule. Whenever you store a Java class inside a package except the default package, you need to declare the package name in the source file of the Java class. So what is the syntax to declaring a package declaration statement? It is first the keyword package followed by one or more spaces, but normally it's just one space, and then followed by the package name. And this package declaration statement must be declared at the top of the source file. And there must be only one package that can be declared for one source file because a Java class is stored in only one package. That's why that Java class file has only one package declaration statement. And a class declared in a different package needs to be accessed with a fully qualified class name. Okay, so say for example, this is class A stored in package A, and say this is class B stored in a different package, say for example package B. Then say for example this is the color class, and class B would access class A, which is stored in a different package. Then class B has to access class A using the fully qualified name of class A. So it should say here package A dot and then class A. This is the fully qualified name of class A. In the fully qualified name of class A, the package name where this class A is stored is included in the reference. So this is the fully qualified name of a class that is stored in a package. The package name where this class is stored, dot, using the dot operator, and then the class name of the class that you want to access or call. But of course, if you're going to use the import statement, which we're going to discuss next, then you don't have to access the class using the fully qualified name if you have an import statement on top of the class. So as mentioned earlier, when another class like this one, array sample, this is the color class. When a color class calls a different Java class that is stored in a different package, then you have to access that Java class using its fully qualified name. So you don't just say array list, but you have to say java.util.arraylist. This is the fully qualified name of Java class array list. Okay, so you use the fully qualified name when the class you are calling or referencing or accessing is stored in a different package. Now this time, let's take a look at how we are going to import Java classes that are stored in different packages. So you import packages when the called class is in a different package, or when a caller class calls or use a class that is stored in a different package. And when multiple classes in a different package is used. So how do you write import statements in your source file? So these are examples of import statements. So first, the keyword import followed by one or more spaces. Normally it's just one. And then the fully qualified name of the class that you're trying to access or call. You have to include the package name and then the dot operator and then the class name. This is when you're going to specify only one class. But if you're going to specify multiple classes, or when you want to cover all classes inside a different package, then you can use the asterisk symbol. So when you say import and then the package name dot asterisk, you are importing all classes that is stored in that package. Now, if you are sure that you will only use or call or access only one Java class in that package, then you don't need to use asterisk, because when you use asterisk, all the Java classes stored in this package will be loaded into the RAM or into the main memory, which will consume so much of the RAM space. So if you are sure that only one Java class is used in this caller class, then you can just specify one Java class that the caller would call or use or access. Okay? Better not use asterisk so that you will free memory spaces. Because in this case, if you use the asterisk, you will be, as I've mentioned already, you will be loading into the RAM all of those Java classes. And that would consume much memory RAM space, or it would occupy so much of the RAM space. And of course, in good programming practice, you are to save RAM space or save memory. As good programmers, you should be very economical with the RAM space. So as much as possible, save RAM spaces. So if you want to access only one or two, then you specify the class name instead of using asterisk. So here we have an example of a caller class. So this is the caller class array sample, and it calls or access the Java class array list. Now in this case, we are not using anymore the fully qualified name of array list, unlike before, because we already have an import statement on top. So we say import java.util asterisk. So all of the Java classes in java.util package are imported or loaded into the RAM and made available to this caller class. And so that when this caller class array sample would call this array list, okay, we call this the called class, and this is the caller class. Then how is this being called? It is called using just the class name, not using the fully qualified name anymore. So again, when there is no import statement on top, then you have to access this by saying java.util.arraylist, and then the instance is list, and then you say new java.util.arraylist. So whenever you access array list, you would always use the fully qualified name of array list. That is when you don't have this import statement on top. But if you have this import statement on top, then you can just refer to any of the Java class that was imported using the class name, not using the fully qualified name anymore. So you could just access it this way. Array list, and then this is also just array list. That is why in our example, we have this instantiation using just the class name and not using the fully qualified name. In the following two cases, the use of import statement is unnecessary. First case is when the class that you are trying to call or access is stored in the same package. So you don't need to use an import statement. You use import statement only when you are trying to access a class that is stored or located in a different package. But if it's within the same package, no need for import statement. And the second case is when the called class or you're accessing a class that belongs to the java.lang package. So all Java classes stored in java.lang, like string and other Java classes inside java.lang, then you don't need an import statement. You can call them directly. In this example, we are using or accessing the string Java class which belongs to the java.lang package. So remember that string is not a Java primitive data type. Okay, string is not included in the 8 primitive data types of Java. String is actually a Java class that belongs to java.lang package. And whenever you use it, you don't need to import. You don't have to say here import java.lang.string. You don't have to do that because again, as mentioned earlier, all the Java classes stored in java.lang package do not need to be imported into the caller class. Okay, you can just access them directly. And the second case is when the called class belongs in the same package as the caller class. So in this case, director is the caller class and employee is the called class. The caller class is director and the called class is employee. How does the caller class director calls the Java class employee? It's in here in this line. We instantiated the called class. So why is that we could access employee directly and no need for us to have an import statement here because the called class and the caller class belong to the same package. Now recall our lesson on encapsulation. So in this example, we are employing encapsulation. As you can see, inside the class sports car, we have a field. Okay, so this is a field. The field name is speed and it is type integer. And take note that we use the access modifier private when we define or declare speed. And so speed is hidden in other classes, even classes inside the same package. So the visibility of speed is only within this Java class sports car. So only the methods inside this class sports car have access to speed. Outside of this class, speed is not accessible or speed is not visible because it is set to private. And in here we have a constructor that initializes the field speed to 0. And we have here the what is speed up? Is it accessor getter method or mutator setter method? Recall that in encapsulation, whenever you set a field to private, you have to provide accessor or getter method and mutator or setter method. Accessor method is used to retrieve or get the value of the private field and make it available or return that value to the caller class. Mutator is for the caller class to change or set the value of the private field into some value provided by the caller class. So what do you call to speed up? Is it accessor or mutator method? Take note that we change here, right? The value of speed. We change the value. So this is a mutator method. While print speed is called to display the value of speed or retrieve the value of speed. And so this method, print speed, is an accessor method or a getter method. Okay, this is setter method. This class sports car is the called class, and the class car user is the caller class. We have here the main method. So this is the caller class that can be run or executed because we have here the main method. And in the main method, we instantiate sports car and creating the instance my car. So via the instance, we could access the instance methods. So we say my car that print speed. What will happen? It will say on the screen speed, and the value of speed is 0. Okay, why 0? Because when we instantiate sports car, we call the constructor, and the constructor, which is this, sets the value of speed to 0. That's why when we call print speed, the output here is 0, this line here. And then we execute this speed up, passing 100 as the new value of speed. The new speed passed is 100. So this is 100 greater. Speed is currently 0. So this is greater. It is true. The condition is true. Therefore, this is executed. So speed now is equal to 100. From 0, it becomes 100. And then after that, we call this one print speed. So the output here would be speed is 100 because we change it here. And then execute this. We try now again to change the value of speed to 50. So this time, the value passed here is 50. And so, this is now 50 greater, the current speed is 100. 50 greater 100, this is false. And therefore, this is not executed. Which means that the speed is not changed to 50. So, you're not allowed to decrease the speed. Okay, you could increase the speed, but you cannot decrease the speed. Okay, so when we call print speed, the output here would be speed is still 100 because it was not changed to 50 because 50 is less than 100. Okay, so that's why we have this output.